Okay, so there's two different things that can occur when we revolve. Okay, so the disc is going to be something that if you look at, it literally creates a circle. Okay, like our little manipulative that I have here. Okay, but it is possible for us to revolve, and imagine like we're revolving around a line that's right here. Okay, like my hand. If I take this space and revolve it around my hand, what's it going to create? Not really. If I only have this space and I revolve it around my hand, but all the way around, it's going to look like a donut. Because there is a space between my hand and this area, right? So when I revolve it around, it's going to have like a hole in the middle. Okay, so instead of calling it a donut, we call it a washer. So if there happens to be a space between the area that you revolve around, then you have to do a separation. So, okay, so we're still doing a pi r squared, but the difference is we're going to subtract the outer edge from the inner edge. Okay? Just like if I was going to draw a 2D donut or perhaps a washer, same thing, right? Okay? If I was just going to find this area, right? I would take the outer radius minus the inner radius. That's what that idea is. Okay? Yeah. Big R is equal to the outer radius, the bigger radius. That's why they use the big letter. Minus the little one.
Like the outside of the donut, right? You're doing the outer radius, you go all the way through the hole too, or just to the
you go all the way to the, so you go from the line of revolution to the outest edge.
Is the line of revolution.
Outest.
You go to like that center of the circle, right? And then subtract that inner.
Yeah, to the inner. Yeah.
Is the revolution the axis? So. Like you're
yes,
going all the way, just
the axes. Well, it might not necessarily always be an axis. Okay, so let's do an example. Let's see if we can try to draw a picture and explain this a little bit better. Which one are we looking at? Big R is outer, little r is inner. Revolution.
Okay, hold on. This is the donut. That's the inner one. This from that?
The outer one is the big R.
That's the big R. Mm-hmm. This is the little one?
Yes.
And are we talking about from this distance to this distance? That's the big R
area.
And the little one is just this little circle right here?
Yep.
Okay.
Yeah, subtract it out, right? Okay. It's got a hole in it.
Yeah.
Alright. Okay.
Wait, what is inner radius then?
Same exact as the outer. From the axis of revolution. Off of the axis of revolution. Okay. So question number 1, we are finding the volume. Okay, of the solid that is enclosed by the curve and is going to revolve around the x-axis. Okay, so most of the time we're going to revolve around the axis, but not always. Yeah, they're in the
just kidding, never mind.
Basket. Okay. Alright, so if I was going to draw 2 times the square root of x plus 4, what does that look like? 2 times the square root of x plus 4. It's a sideways parabola. If it has a plus 4, which direction is it shifted? Which over?
Right.
Whoa. Left.
That's what I said first.
Oh, I didn't hear you saying. So it has a slope of 2, so it goes up 2 over 1, so it looks something like that. Okay, y equals 0 is just the same as the x-axis. Okay, x equals 1 is a vertical line at 1, so I'm just going to actually enclose this right here. And then x equals 4 is right here. It's in the problem.
Yeah, what color are you?
Just number 1 right here on the my examples. No, nope, this is my worksheet. Okay, so all we're going to do is we are going to take this slice and we are going to revolve it around the x-axis. So you can kind of imagine the way this would look. So if I took this, it's almost a rectangle. So if I circled it around, it would almost look exactly like a circle. Well, maybe almost kind of like this fan right here. You see what I mean? So maybe like half of this side. You guys see what I mean? So it's slightly curved a little bit here, but imagine that. It would look actually pretty similar to it. Okay. So is this going to be a disc or is this a washer? Okay, so this is a disc, and the reason we know is because there is no space between the area and the line of revolution. Okay, so this is a disc. Okay, so the
Wait, so the y-axis is the line?
no, the x-axis is the line of revolution.
Oh, I guess that makes sense.
So we're going this way. If it was around the y, then it would be a washer. Okay. All right. So the volume, by definition, if we're doing a disk, is pi, the integral, r squared. What's my integral bounds for this one? From 1 to 4. Good. Of r squared. So I'm just going to leave the r for a second here because I want to think about what is the value of r. Okay, r is representing the radius, so what do you think is the distance of the radius?
Oh, then it would just be like it's
125.
Okay, so if I was going to represent this radius, it's going to be the distance from this line to our curve. So what is the distance from this line to this curve? 4. Well, not always 4. It's not always 4. It changes. Okay, the distance from here to here is just the equation of the y right here. It's just 2 square roots of x plus 4. Okay, so my r is just 2 square roots of x plus 4. Okay, so now I'm just going to plug that into my volume equation. So we're just going to have 2 square roots of x plus 4 squared. True, yeah, you'd have to make sure that you square the 2 also. Okay, so at this point I'm going to let you plug this into the calculator. Okay, so you're mostly practicing setting up the integral on this assignment. Does anybody want to type that in quickly?
Wait, how do you get the integral again?
Alpha window. Is everybody okay around you? That's a pen.
I'm gonna have to watch you.
What's that? 78 even? Wow. That is beautiful.
To watch you graph it again. I wish it.
Okay.
I didn't get that.
Or not graph it, but
I don't.
I know my head is so far.
Like it's.
Oh.
Do you want me to type your wrong Oh.
Let me see that because that looks right to me. I think this is right. Ruby, I think maybe double check because Gracie got 245 and the way I'm looking at this, it looks correct. So when you type it in the parentheses, you have to type after the integral parentheses 2 square roots of x plus 4 end parentheses and then squared.
You do the times pi?
Times pi?
is someone in radian and someone in degree?
I read the pi.
All right. You just type of. All right. Should I do one more like that?
Yes.
Let's do
Do a different one.
Let's do a washer.
Okay, let's do a different one. Let's try this one. So question number 3 right here. Okay, so we're doing the same thing. Shh, girls. Okay, so this time we are revolving around the y-axis. Okay, so when I revolve around the y-axis, guess what kind of integral I'm going to do? A dy. If I revolve around an x, I do a dx. But if I revolve around a y, I do a dy.
What does that?
Should I say that one more time?
So does it
Changes your bounds.
Oh, obviously, because the meanings of y.
Right.
Okay, that makes sense.
Okay, so my first equation is x equals y squared. Anybody know what that looks like? It's a parabola, but it's turned on its side. So if it's in terms of y, everything just gets turned over.
Oh, that's funny.
2, 4. Oops. So it looked like true. I can't disagree with you. Okay, what does x equals 0 look like?
The line at the y.
Good. It's the y-axis. X equals 0 is just the or the y-axis. And then what does y equals 2 look like? Y equals 2. Horizontal. Out 2. Okay, so the area that we have is this little, right here, little choke. Okay, so this area is revolved around the y-axis. Okay, so can you kind of imagine it getting revolved? It kind of would look like, kind of almost like a funnel. You know those things that you drop
It would look like a
well, it would be flat on the top, but the sides would come in all the way around. Okay, so is it a disc or a washer? Okay, it looks like it's a disc because we're revolving it around the y-axis, and this area touches the y-axis the entire time. Okay, if we were going to take this and revolve around the x-axis, coming around this way, that would create a washer. Because there would be space between the function, the area, and the line of revolution.
Wait, so are you revolving it around y equals 2?
We're revolving it around the y-axis.
So x equals 0.
Right.
What if it's the same formula if it's like pointed at the end?
Wait, what?
The
formula?
It goes around kind of like that.
Mhm.
So wouldn't the formula?
If we were revolving around the y-axis, yeah.
Yeah, it touches the x.
Yeah, but not the whole time. It has to touch it the whole time because if we revolved it around the x-axis, so imagine this location right at 2, for example. At 2, there would be a space between the x-axis and that area. Like right there. Yes. 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 So this is a disc. There's no hole. Not on this one. This is a disc. Okay.
I'm still confused what the point of it is because it's not like this. Like it's just like all there.
But okay, so we are revolving this around the y-axis. This is the y-axis. So when I revolve this area, it will always be touching it.
Oh no, I get that. I get that. It's like the shape of it. Never mind. Let's just go from this.
Okay, so the volume is pi r squared, so pi, okay, so remember that this is a dy, so what are my bounds? Okay, so what are they? What are the numbers? 0 to 2, we're going to y's. Okay, so r squared, so now let's think about the r for a second. Okay, so since we're revolving around this way, okay, my r would be this length from here, from my y-axis to the curve, which is my equation. So what is my r going to be?
Y dy.
Mm-hmm. dy, yes, and I just did say that. Thank you. What?
What's after your?
Good job.
R squared. Okay, so then we just plug this in. So it's just going to be pi times the integral from 0 to 2 of y squared.
Heard you?
Okay.
No, she just gave him a picture of a dog or a coyote or something. Oh, Johnny's not.
All right, we good? Did anybody get that number? Huh? No, I want you to give me the answer. But
What?
everybody's distracted, so I'm just going to move on. Who's doing it? I don't see anybody on the calculator.
Got it.
Maddie?
Who?
Am I?
You want me to solve it? I'll solve it.
Remember, you can't use y, so you got to use an x on the TI-84s. You have to use an x always.
20.1.
20.1. Anybody else get 20.1? Okay. All right. So let me explain now what a washer will look like. Okay. So I think that this is going to be a washer.
That's around the y-axis.
Okay. So this time they're telling us that we're going to revolve around y equals 1. Okay. So this will be a little different. So first I'm going to graph the square root of x plus 1. So what does that look like? Plus 1 moves up 1. Okay, squared is just the sideways parabola. So it looks like that. Okay, what does y equals 1 equal? Or look like? Or, okay, y equals is horizontal. Wow, I can't draw a straight line. Try again. Ooh, harsh.
You're the one who did it to me first. And then X equals 1.
Oh, this is not a washer, dang. Okay, so my area is this little itty bitty spot. Ooh, actually, this will be a good example to do. So, if we revolve it around y equals 1, is it going to be a disk or a washer? Okay, it still is a disk because it's that area is touching our line of revolution.
If it's touching
Okay,
line
so,
of revolution.
yeah, if it touches it the whole time.
So if it's around, going around, like, the y, but it's not touching that, so there's going to be that hole.
Because we already know what a disk is.
Okay, so if we revolve it around y equals 1, is this integral going to be a dy or a dx? Dx. Okay, because y equals 1 is parallel to an x-axis, right? So it's still, we're still revolving it in that same way. Y equals 1. So we still have that same. Yep. So anything parallel to the x that you revolve will be a dx.
But we're going to the same answer, right? Whether you write it.
Well, if you revolve around the y, you have to have a dy equation, which means you have to take your y equation and solve for x when you put it into the integral.
Yeah. Anything parallel to the x-axis.
Anything parallel, yes, forever. That is a forever rule.
Until the exactly. So cosine and sine, and then everything's out the door. Not sine here. So what's your r squared?
Okay, so let's talk about the r. So we got to be really careful here. The r. Okay, the r is the distance between the y equals 1 line and our function.
Oh, it's x.
So what is that difference?
X
Distance.
1. No, oh, sorry, no, it's the square root of x. Take away
Right. Okay. So when we have a space between the x-axis, it's going to be a top area minus bottom. So this would just be the square root of x plus 1 minus the bottom equation, which is 1.
Oh my goodness.
So the radius is the square root of x for this. Yes, Haley.
Okay, so when what we're solving is the shaded in part, right?
Say that again.
What this equation is equivalent to is the shaded in part?
Is the shaded, yeah. Okay. So what we're finding is if that area was going to revolve around the y equals 1 line and create a 3-dimensional space, we're finding that volume. So this one will be really little because it's not a very big space.
I got it.
Oh, you got it already? Okay, so what is our integral bounds going to be between? 0 and 1, good. So if I plug in my r, it's going to be the square root of x squared. And John, you got this for me? What is it?
1.5707 times.
Wait, what?
1.57 what?
07.
So 1?
Why is it not x squared plus 1 in there?
Because
Or not root x plus 1.
Because you see how our area is shifted up? It's not the area that exists between the function and the x-axis. We have to subtract out that one little unit between the y equals 1 line.
Oh, I didn't even see the minus 1.
Woo!
Easy to.
Almost lost my chair. Okay. All right, we need a washer, yeah?
Yeah.
All right, let me see.
So for the washer, will we be finding the volume of the hole?
Yeah. Well, you have to subtract out the volume of the hole. So that's why it's big R minus little r. Yes.
Yeah, let's do number 4 on there.
All right, let's try number 6 first, and then we can always help each other. Okay, so number 6 on this here, we're revolving around the x-axis. Okay, and we're bounded by, we got 4 lines here. So my first one is negative x squared plus 2. So what does that look like? Negative x squared plus 2, what does it look like?
This way.
It's up to.
Okay, it's up to, it's upside down, and it's a parabola. Yeah. So it looks like,
Should I have this in my notes or can I just watch this?
well, you can watch it and then write it down if you want. Okay, y equals 1. What does y equals 1 look like?
I'm going to though.
Y equals 1 is our horizontal line up 1. Oh, that was bad. Dang it. Okay, x equals 0 is just the y-axis. Okay, and then x equals 1, I feel like this is not even needed. It'd be right there. So do you see the area that is enclosed? There's a lot of lines there. It's right here. My area? What? I'm pretty sure that's pretty solid.
I'm not saying it. Okay, can you explain how it looks?
Oh, I haven't talked about it yet. Okay. So we are going to revolve it around the x-axis. Okay, so the x-axis is right here. Okay, so if I take this little, it kind of looks like almost a triangle. Okay, and I revolve it around, it's going to look like, it really looks very similar to a donut. Okay, but the edges of the donut would be very straight instead of curved like a circle. Okay, but the outside edge would be kind of curvy like a circle.
Okay, so the line touches the x.
You lost me at the curvy part, but.
Well, because this outside edge, because it's an x squared, is a parabolic shape. the outside edge would be curved like a bracket.
Yeah, so then this part would be like.
The inside is flat.
Do we need to think about that to calculate?
Not technically.
Okay, good. I'm not going
This
to.
is really.
How is this a donut? It touches
It touches the x-axis, not the x.
Is black a solid piece of something?
Yeah.
That's what's going to happen. Okay.
Take that little piece and imagine it circling the x-axis.
Okay, so if it doesn't touch the revolution, like the axis revolves around,
Mhm.
then it's the thing.
Then it's a washer, yes. A washer or a donut. All right, so the equation for the
Yeah, but it
no, because we revolved around the y equals 1 line. That was what was different. Okay, so we're gonna do pi, and then we're gonna go from what to what? Okay, yep, 0 to 1. Okay, and it's gonna be a big R squared minus little r squared. Okay, we're doing a dx. Okay, so when you're working with the washer, you have to figure out what the big R length is and what the little r is. Okay, so the big R, let's see if I can draw my picture. You everybody ready? Okay, the big R is the furthest length from the line of revolution to the outer edge of your area. Okay, so if I'm going around the x-axis, my big R is going to go from the x-axis to this edge. Is everybody okay with that? So 2. Okay, now it's not always 2, it's to this curve. So what is the distance from the x-axis to that curve? Negative x squared plus 2, right?
Wait. Oh, gosh.
That's my big R. I should draw it in red. I feel like it makes me fun. Is everybody okay with that?
X-axis.
Okay, my little r is going to be to the inside of my area. So if I go from my x-axis to the area that I like basically have to cut out, that's going to be that area or the distance from the x-axis to the lower line. Okay, what is the distance to the lower line? Okay, and that one will always be 1 because it's a flat line. Okay. And you can, in fact, always just use the lower equation.
will big R always be like this?
It's big R is always the top equation, the distance to the top equation, and your little r is your distance to the lower equation of the area. Okay, so if I plug this in, we'll have negative x squared plus 2 squared minus 1 squared dx. Okay, so you can type that into the calculator. Minus 1, so minus the little r. That's the little r. You gotta subtract out the whole.
5.86.
Okay. Is everybody okay with that?
Yeah. Now let's do.
Okay. You want to do one off the homework?
Yes, can I get the worksheet? Mine is like in my car.
Okay, which one? Which one is the hardest? Should we start at the back and work forward?
I say we go from the hardest one.
Or do we assume the hardest one is at the end?
Sure. It's usually like I get this, and then it gets like lost in like I don't understand.
Oh, wow, we have 6. Okay. Okay, so we'll start at the end. Okay, so we are revolving around what? Okay, so we're revolving around y equals 2. Everybody with me? Where's your worksheet? Go get one in the basket. Come on. No, you haven't started it yet. Okay, so negative x squared plus 5. What does that look like?
Up 1.
Upside down parabola, that's what?
Up 1.
Up, huh?
Up 5.
Up 5.
Oh, I thought you said plus 1. So, yeah. Wait, no, that's just off my worksheet.
But we're starting at the end.
Oh, wait, you're finding that one.
Okay, if I was going to draw y equals 4. Okay, so that immediately just binds in that little tiny, kind of looks like a hat. Like a stocking hat? Oh, you guys see it? Okay, my line of revolution, I'm going to draw this in a different color so we can kind of imagine it. So my y equals 2 line is right here. So we're revolving it around y equals 2. So that red line. Okay, so is this a disc or a washer? Okay, it is a washer. Good. Okay, so since we're revolving it around y equals 2, are we doing a dx or a dy? Dx. Good. Okay, so it's going to be pi. What are the two bounds we're going to be between? Negative 1 and 1, so that you're doing it in x's. Wow, that's a negative 1. So then we'll have big R squared minus little r squared.
Wait, how do you know it's negative 1 and 1?
The x value of the area that it exists between.
Oh, like set it equal to 0.
Well, like, look at the drawing. I just looked at the drawing.
This part on the left with the like area touching this part on the right is touching.
Little r squared?
Like here.
Oh, yeah.
Okay, like you see the little drawing right here? This x value is negative 1 and this is 1.
Oh, it is?
And so, I mean, yeah. So it's like,
My drawing's just not very good.
That helps to make sure your points are pretty exact. Okay, so big R. So big R is your distance from the line of revolution to the top of the area, the furthest distance away. So what will be the distance between the y equals 2 line and the top of our curve? Ooh, nice, good, good. Okay, so negative x squared, technically it would be plus 5 minus 2. So I did hear somebody say negative x squared plus 3, right? Everybody okay with that? So that's your big R. Okay, so your little r, that's your inner piece. So your distance between your line of revolution and your lower area. So that space will always be 2 because it is a constant. Good. So now we can plug those in. So negative x squared plus 3 squared minus 2 squared. And you got? Go ahead. Did you think that was hard?
yes.
You were so smart.
I've never been so actually understanding something.
Good.
So for number 15,
Okay. Area? Uh-huh. Revolution.
No, like the, so like it's literally just like this full line. Yeah, the integral.
Oh.
Would it be the exact same as the negative?
So there's a little r you're going to
Okay, are you guys good or do you need me to do more?
I think we're good.
Good? Okay.